Hey everyone, my name is Ryan, and today we are going over the 5 most useful Windows commands. Feel free to go through the video in the chapters because I plan on going into a ton of detail for each command. We are going to be going over how to run the command itself, and of course go into the details of how the command functions and what it's doing. And we are going to go through how we are going to be using these commands to help improve our everyday life. All right, with that being said, let's get into it. All right, the first thing we're going to do is just open up command prompt. Now there's a couple ways to do it. We can go to right-clicking the start menu, press on run, you'll get this little box and you'll just type in CMD for command prompt. Press OK, and you'll get the prompt come up right here. Another way to do it is going into the start menu, typing CMD, or you can type in command prompt, the whole thing if you wanted to. Press enter. And it pops up. Sorry, it's on my other monitor, but here you go. And that's really it. So we can get started with our commands now. All right, our first command is going to be the ping command. This is the most used, most well-known and simplistic thing that you can use. But I'm telling you, it is so powerful once you know how technology works and what this thing can actually do for you. So ping, P-I-N-G, and to actually use it, you would ping either an IP address or something like a website or a host name. We can go over those things in detail, but as an example, ping google.com, which means we're just sending off some pings to the website. Okay, by default, I'll run these couple. Now with this information, what we can see is the IP address that we're actually pinging. So the IP address 64233.177.101 is associated with google.com. These are technically the same thing. This is just the name for the IP address. And here you can see the time it took for our packet, which is our ping, to reach google.com. And this is 19 milliseconds. Generally speaking, that is plenty fast. Anything over 200 is usually where things get slow or dropped packets and things like that. Packets here, you can see we sent 4 because we have 4 pings, 1, 2, 3, 4. It received 4 and lost nothing. So it's a great way to see packet loss here. And packet loss just means that all of your data is not getting to the point that you want it to be. And if you ever get packet loss, things won't work correctly at all. Okay, now that we saw how to actually ping things, like google.com, you can ping IP addresses too, like I said. We are going to go over what it's actually doing and how it works. So ping uses something called ICMP. Trying my best to write with my mouse, so don't judge my handwriting. I thought that came out pretty good. ICMP is a protocol that allows a device to respond to pings. So by default, every Windows computer or Windows server and things like that all allow this protocol through, so you can generally ping anything you want and get some type of feedback. If ping does fail, and as an example, if we ping something kind of random, right, 192.168, and this doesn't exist, nothing's gonna happen. It just can't respond. The device either doesn't exist, the device is offline, or the device is blocking ICMP in its firewall. That's a little bit more advanced, and sometimes servers or web servers will do that for security purposes. But by default, if you're working in like a home lab or a home environment, or you're trying to ping one of your devices in an office or again at home, it should be enabled by default. You shouldn't have to mess with firewall settings. But those are the 3 situations that you could possibly run into. All right, now to really get into the real practical applications of using ping, and this is just a scenario. It could be applied to many different things, but we will be here forever if I keep going over scenarios. Now we're gonna go over this fantastic drawing by me. So here we have our home PC, our router, and the internet. If for whatever reason we lose an internet connection, that would be pretty obvious when you're at home or in an office. This could still be an office if you wanted to use this for like your IT troubleshooting. But anyway, if you lose internet to a device, you can ping google.com and it'll return nothing like we went over before. And that means that you can't reach it. But realistically, you don't know if you don't have internet or maybe your router actually died. Because if your router died, you also can't get to the internet. So what could be super useful is if you know your router's IP address, say 192.blah blah blah, right? If you try to ping this and it does not ping, that will mean that your router's probably dead. Or there's an issue, maybe power outage. It could be a number of things, but you'll be able to eliminate the fact that it's not the internet that's the issue. And it's not your ISP, your internet service provider, that's the issue. It's internal. So it's like within your office. This is your office here. And between your PC and the router could also be a switch or different devices, a different firewall, and things like that. And this still applies. If you ping that device and you can't ping it internally, even if you have no internet, that means there's something up with that device, and you can, point your troubleshooting efforts towards that device and just check on it. So this is probably what I use it the most for, is this troubleshooting effort when things aren't connecting or working. Maybe it's a PC to another PC inside of the office. Ignore that P. Again, I'm using my mouse. Here. And the same exact rules apply. If you try to ping this computer and it doesn't work, it could be something between these two that's failing and not the internet, or maybe it's not the PC that's broken. It could be something between. And using this ping tool, you'll be able to try to narrow down where your troubleshooting efforts could be. Now we are going over our second command. This is basically ping's twin sister. It is called traceroute. And you can use this almost in the same way. You would trace route to a website or an IP address or a host name. Okay. And what this is doing is basically telling you each hop that it takes between devices. So the path that it's taking to get to the source destination that you are listing right here. So this will be your destination, and this is technically the source it's coming from. So this would be your gateway, or basically your router, to keep it simple. And then from your router, it's going through this location to this location. These are probably not pingable because the ICMP is blocked or something like that. And it'll just keep on going and listing out all the different locations of how it's trying to get to google.com. And on top of that, of course, it's giving you the time each hop is taking. All right, now that it's finally completed, it took a while, you get all of this information, and let me tell you how useful this can be. First things first is this is our home network. This is our router, AT&T. That's what I got. And after AT&T, it's just going through all these different devices, probably blocked stuff from ICMP, so it's just not returning anything. And then it's just, hopping and going, different devices. It's just how the internet works, essentially. And then finally, on the 25th hop, we get to this address. And this is pointing directly at google.com. There could be some technology that helps filter it and protect it and whatnot, so this IP address might not be completely accurate because of proxying. But this is telling us that we went from this device to this device and how we got there. Now, another super useful way to use this is not just pinging or a trace route to the internet. It is a trace route to something internal. For an example, if we go to our gateway, which should be this, It's telling us that we can get directly to our gateway. It's one hop. It's not going through any other devices or switches or weird things like that. And we're able to get there very easily. Now, if you have another device, we're going to be going over this command. Don't worry. I'm just looking for another device. And we try to tracer out to it. Yeah, I'm just pulling this address right here. Again, it is one hop because it's internal. It's not doing anything else. We're getting routed directly there. So it's super fast, super convenient, and it gives us some information. Now, if you have devices in between this, it's hard to do that here because I'm not doing this off of my home lab or in an office where there's a lot of devices. Sometimes if there's connections between an office and different locations, you're going to get your gateway, and then you're going to get all these hops like I did with google.com. And then eventually you're going to get to the other office and you're going to see if that connection is working properly. And again, it's the same idea. You can use this to troubleshoot things just like you would troubleshoot with ping, except you can see each device that it's trying to get to. And that's how you troubleshoot. You find what device it's failing at and then point your efforts in that direction. And it works beautifully and it's used so often. If you got this far, please like and subscribe. I did just start the YouTube channel, so all the support is really useful to me. It helps encourage me to keep pushing out more and more content. I got so much stuff down the pipeline that could be really useful to everybody. So again, thank you so much for watching this far if you are still here, and check this out. All right, so our third command that we are going to be running, CLS, just kidding. That is just to clear my command prompt. You can use that if you want. It just makes it a little bit cleaner. Our actual third command is the one that I use to find a device. That will be arp a wabam. What this is doing is using an ARP table, and this is address resolution protocol. And this ARP table is essentially telling you everything that your computer sees or is speaking to in technology terms, I guess, in zeros and ones. It can speak to all of these different devices. You can see that I have different interfaces. You can kind of ignore those. Let's go to my normal home address here. Most home addresses will be 192.168.1 or a .0 here. And this will typically be a normal, home address interface. These are stuff due to home labbing and things. You probably won't even have these listed. But anywho, here you could see all the devices that I can currently see with my computer. If you don't have all of those listed, if you do a ping 192.168.1, ping your gateway and then stop it. You could stop it by Control-C if you wanted to, and then do another ARP-A. Your devices that are able to speak to your computer should show up. This won't be everything, because some things like arbitrary devices on your network with an IP address don't actually talk directly to your computer, so it won't be listed. It'll be listed in somewhere else, like in your router settings or a core switch that's actually logging this stuff as like a MAC address and all this other stuff, or MAC table rather. Anyway, I mean, this is straightforward. I showed you exactly how I use this command already, and it is to find devices. I needed something to ping. So I typed in arp-a, I found something to ping, and I pinged that address. And, it's actually quite straightforward, but it can come in handy when you're trying to find something on your network. Again, this could be home or office networks. Now on to our fourth command. I'm going to go ahead and clear this, and we are going to do nslookup. What this is going to be doing is essentially telling us the address to a name. So it's going to give us an IP address, see all the addresses listed out for google.com. Or we can do nslookup of the IP address, as you'll see in a second here. And it's going to give us the name of where that's coming from. If you recall, the last time we ran a trace route, the last device of google.com ended up resolving to this. So that's why we're seeing this here. It's a little better and more useful when you're doing this stuff internally in an office with lots of servers, or at home in your HomeLabs and things like that. Because you will find things like this. And what this is doing is telling us that this IP address belongs to this device, and it gives you the name. And you can do this for other computers. So if you look up a computer IP address, it's going to give you the host name. And I'm telling you how useful it is to know the host name of a device. It's fantastic. And then the opposite also occurs. If you look up the host name with nslookup, it returns the IP address. So as an example, let's look up this whole thing. I'm gonna type it out. I should have copied it. Too late. Can't type. Google.net. See, so this will be the host name. You can punch in a server name. You can punch in a computer name. Works the best on home networks and not things out on the internet. Of course, it still works on things out on the internet. It can be used for very niche troubleshooting or just getting general information. Because come on, I'm pulling the IP address using a name. Super easy, super convenient, and it provides this fantastic amount of information. Now let's go over a little bit about what nslookup actually is, because just because you know that it's, you type in the name and it gives you an address, and you type in the address and gives you a name, what the heck does that mean? So let's go over DNS. I'm gonna probably make a whole video. You could probably make a whole series of videos just on DNS. But we're going to give a brief overview so you can at least understand it a little bit. Now, DNS is essentially where you take a name and you associate it with an IP address. Because who's going to ever remember IP addresses? If you need to get to google.com, right? If I punch this into my web browser, I go to google.com. It's kind of cool. But who the heck's going to remember that? You got to remember 142.250.105.101. You're not, no one's going to start remembering all these names. So we have DNS. And DNS is you associate a name to this IP address. So instead of, typing this whole thing out and remembering it, you just need to remember google.com. This is almost the whole purpose. It's to associate these two things. So you have a name with an IP address, and that is done on a DNS server. Now to go over DNS servers, that's a whole other ball game. Real briefly, typically at home, you'll have your home computer connected to your router. Name it R. This is P for P. I'll just name it PC. And you need to get DNS information, because where the heck is this and this combined? Where is it stored? And for the most part at home, this is going to be stored with your internet service provider. Your internet service provider is going to have like all these DNS servers. So it goes out to these DNS servers and it picks this information up. Say Google is, that address 142 blah blah blah, right? So this sends it back to your computer, so your computer can utilize google.com and actually resolve this. If it didn't have this DNS stuff, it would never know what this is. And in an office, in a work environment, it's usually this same deal. except your DNS server is probably hosted within your company. So your company will spin up a domain controller. That domain controller has a DNS service on it, and then it'll perform this same process. If a DNS server can't resolve an address for you, it basically just looks up the chain to another DNS server. And then if this DNS server can't resolve it, it's going to look up to another DNS server. And they're all just interconnected basically forever. There's a lot more detail to this, but for basic understanding, this is how it works. And now it can, resolve this stuff for you. And it's a beautiful, beautiful process. Whoever came up with this is, they're a freak. I don't get it. Learned it, but it's crazy to come up with it. But anyway, that's how DNS works, and this is why we use nslookup. Because technically, this is name service lookup, and if you put D in front of it, that's DNS. See, makes sense? That's how you remember the command. All right, now that we got this far, we got one more command to go over. Hear this one more time, and this is, man, I might use this more than ping. And that is going to be Ipconfig. We can also do Ipconfig all, and I'll go over both of these. Now, mine's going to display a lot more information than yours probably because I have a bunch of adapters due to labbing and stuff, but it'll still generally look the same, and we can go over all of this. So Ipconfig returns all the information on your adapters, and that's your Ethernet adapters, the things you plug your cable into, your Ethernet cable. Or it could be a wireless adapter, which means things that connect to your computer wirelessly. It has an adapter inside of your computer, and this just displays all of that information. For example, here you can see, this is IPv6. For example, here you can see my Ethernet adapter has this IP address, this subnet mask, and this gateway. The gateway is usually a router or a firewall. The IPv4 address is just pretty much the name of your computer. Let's just go with that. If we wanted more information on our adapter, which we usually do when we're looking at this kind of stuff, all you got to do is type in ipconfig/all. Now you can see I get even more information. I'm getting my host name, node type, you get all this crazy stuff. And then of course here. And now here's where the magic is. This is what you want to usually look at. You get your IP address, subnet mask. These very two useful pieces of information when you're troubleshooting things or looking at information on a computer. You can use this stuff for nearly everything while you do that. Then of course you have your default gateway and your DHCP server and then your DNS servers. These are the next big, the wrong things. The next three big things that you usually look at and find out a lot of information. Now, when you're at home, it's a lot more simple because your DHCP server, your DNS server, your default gateway is your home router. They're usually all doing this for you, so you don't have to worry about it. But when you're in an office and you have a complex work environment and you're trying to look for different things, different issues, is your computer looking at the right DNS server to resolve all of the right IP addresses to host names? Again, we just went over that stuff. I know it can be a little bit convoluted to absorb all of the information that I'm putting out here, but this is how you can begin to troubleshoot on a computer standpoint instead of the internet or devices after a computer. Probably my best example is a DNS server in an office is going to be a server that gives your computer a DNS server to point it at itself, essentially. And if that's not on the computer correctly, your computer will stop resolving all of the IP addresses in that office, or not resolve them correctly or all of them. It'll only be able to get out to the internet if that. So it's one of the things that you just need to look at. Make sure it has the right DNS server. Make sure it's DHCP server is correct. That's another technology I can definitely go over. Short version is it hands your computer its IP address right here. That's what the DHCP server does. It just gets an IP address. It has a whole list of them, and then your computer talks to it, and it takes one. It leases it. It's renting an IP address for a certain amount of time, and there you go. There it is. And of course, if you keep going, you'll see your different adapters. You probably won't have VMware stuff, but you might have your wireless adapter on here. I'm on a desktop, doesn't have a Wi-Fi adapter, so you won't see that. And it'll have its own information just like this. Again, it's super valuable for troubleshooting, and it just gives you just an abundance of information for a device. And that's it for all of my commands. Now, I do have one honorable mention. This does not apply to home networks, but my honorable mention is the other command that I use the most in an office. Keep in mind, in an office is gp update/force. If you guys know what group policy is, awesome. I'm not going to explain it in this video, but please use this command as much as you can, because it gets all of the policies in an office onto that computer, and it's a beautiful thing. And if you press enter, if you're on a home computer, it's not really doing anything because you don't have policies applied to you. But if you're in an office, this is what it's going to look like. It's going to be computer policies is successful, user policy is successful. You can also run a GP result to get the information on the group policy, and that's all. Again, another whole ordeal, but very useful. If you're an IT or a technician, please use this while you're troubleshooting, as it'll make sure that all of your company's policies are applying to that computer correctly. But really, that's all I've got. Thanks for watching, everyone. I hope you loved the video. Again, please like and subscribe. I'll catch you in the next one. Thanks. Bye.